Question 52. Here, there are two challenges. It's not a hard question, but it would be if two things. First of all, if your English is not very good, and even if your English is good, if you're not a native speaker, it could be tough to understand what they want. And second of all, and more importantly, um, I looked up, you can just high school geometry sentences, and there are several YouTube uh, playlists or long videos by several people. I'm not being paid for these videos. I don't care about, I'm not going to recommend about anyone if they tell me. So, yeah, of course, Khan Academy, which is very famous, but there are many, many things here that you can use um, just to know the postulates and axioms of geometry. If you don't, then you just need a very good intuition or abilities to be able to solve such things. Let me show you what I mean. Um, let's read the question. It's going to be a little bit hard, but let's try. Let theta be the acute angle formed between the tangent at the point A to a circle and one of its chords AB. So initially, I'm trying, it's supposed to be a circle. And here we have this point. Okay, I'm reminding you that I read this yesterday, so it takes some time to understand what they want. But this is point A, and we have the tangent. It's supposed to be a tangent line. It's supposed to tell us, but it's a tangent line. Yeah, that just touches at one point, touches the circle, and then um, the acute angle is the angle smaller than 90 degrees, formed between tangent A to a circle and one of its chords AB. So let me put a point here, B. Let me connect here a chord, um, that's the line that connects between 2 points on the, and then this is theta, and considering any point D on the larger of the arcs AB, look, this is arc AB, the small one. This is the large one. Um, considering any point D on the larger arcs, let's just whatever. This is D, um, denoted by phi. So this is phi. No, like this. Angle ADB. Yeah. What relationship exists between theta and phi? So turns out that they are equal just by definition. So if you know the postulates of Euclidean geometry from high school, you will know this. So um, let me try to maybe give intuition, maybe. Um, it is hard, but I do know to tell you that, and just very briefly, we have this here, and um, we have theta from the question, and we have the other one. These three colorful angles sit on the line, so together they're 180 degrees. And also inside the triangle, this angle and this angle, and again the red angle, are also 180 degrees because they're in a triangle. So all that is needed to be added is that they would be like B would be equal to this, and D, like phi, would be equal to theta. What I think that you should do is just take this chord, bring this to here so they're parallel. Then because they're parallel, you can show by identity between parallel lines, you can show that these angles are equal. And then angles that sit on the it's called, I think, circumferential angle that sits on the circumference. If the chord it sits on is the same, they're all well, always going to be the same. So this is kind of a proof. I don't know. I hope I'm making I hope I'm clear, because I'm just trying to give you intuition about why this is correct. But I wouldn't have assumed immediately that this is these two angles are equal. I actually Googled it to find instead of working hard. So yeah, for high school Euclidean geometry, I would suggest that you just like read and understand the main ideas and main postulates of it. And I will see you on the next question.